Today I start on important topics related to normed linear space. I start from one question, okay, and this question shows that C the set of all convergent sequence. C the set of all convergent sequence, okay, set of all convergent sequences with in K, obviously in any field K, and with norm x equal to supremum of K belongs to n mod of xk, where x belongs to C, okay, this space C. Then what happened, then this space with respect to this norm is a Banach space, okay. So easily we have done it. Just write this statement now, okay. What we do now, we're going to proof of that. So right here proof. First we assume that, what we assume that this C with respect to this norm given here, okay, this norm be a norm space. We not prove this, we just assume this, okay. This one happened in, we also in previous class we also prove it, but today we also not done it, okay. So we assume this one. Now we're going to what we have to do. What we have to do, we have to show that right here, we have to show that C norm be a Banach space, okay. Then this means what? This means that is C norm be complete, okay. That means this one is norm space. We also let this one, and then we shows that if we shows that this one is complete, then done. So if this one complete, then what we have to do? We have to do first to take or let one Cauchy sequence, okay. Let xn be a Cauchy sequence, in C norm infinity, okay. Then what happened, where xn harm, that means which structure this xn form or carry. First we write this one, which structure this xn carries. So we write this one now here, x1 whole to the power n, x2 whole to the power n, dot 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 xk whole to the power dot dot dot, okay. Then what happened, this one be Cauchy sequence, then let epsilon greater than 0 be given, okay. Let epsilon greater than 0 be given, and there exists n0 belongs to this natural number such that what, that means xm difference xn, two term, this one m term, this one n term, not to the power m, this one just suffix, some suffix, okay. Then this one with respect to this norm obviously less than epsilon for all mn greater than equal to n0, this n0, okay, some natural number. So now we use this definition of norm. What given here, norm k belongs to n mod of xk whole to the power m, xk whole to the power n less than epsilon for all mn greater than equal to n0, okay. Then what happened, this one, if supremum is less than, then this one is less than, yes or no? I think yes, okay. Then we write this one now, not a problem at all. Now we also further proceed. Then what happened, then we also find this one here m, and obviously we talk about that for each k belongs to this natural number. Okay, and obviously n belongs to natural number x k n be Cauchy sequence in where in k some field k. So we know about that k be complete. So simple this one. So we know about that since k be complete. Okay. Then what happened? Then obviously this Cauchy sequence convergent in k. So we write here xk whole to the power n as n tending to infinity equal to xk, and this one belongs to k. Yes or no? I think this implies this one. Yes. Okay. Now we define what we define. We write here again. We define x equal to x1, x2 dot 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 xk dot dot dot. Okay. Then what we have to prove? We have to show that obviously we write this one is x. Then what we have to show? We have to show that this x belongs to obviously c. Okay, this x belongs to c. If we prove this one, then that means our this necessary condition is done, or our proof is done. Okay, so what we do now? Also further proceed. Then what happened? Then here we think about that xk difference xp, okay, less than equal to what? Less than equal to, if we write this one xk different, sorry, not less than equal to, first we write equal to what? Xk difference xk n0, okay, plus xk n0 difference xp n0 plus xp n0 difference xp. This less than equal to what? Xk difference xk n0 plus xk n0 difference xp n0 plus xp n0 difference xp. Okay. Then what happened? Obviously we mark this 2. Okay. First we that means first we not marked here, but this one is needed. This one is marked 1, but we write now later. We just that means write this statement again. So what is given in 1, that means that is not marked. This one xk whole to the power m difference xk whole to the power n less than epsilon for all m n greater than equal to n0 and k belongs to natural number. We mark this one. Okay. Then from this what happened? Then from this we also take or taking m tending to infinity. Then what happened? Taking m tending to infinity, then obviously this one is converts to xk. Okay, so what we find here? We find this one here xk difference xk whole to the power xk suffix n. Okay, we write it bracket then better, but we not write bracket in first, so we write same thing. Okay, we not write here bracket because we first we not write this bracket, so this one is not needed. Yeah. Okay, just this one is not to the power some suffix. Okay, this one not needed here. So what happened? Then taking m tending to infinity, this n less than epsilon. Okay, for all n greater than n0, because m is here obviously vanish, then k belongs to n, natural number. Okay, then what, that means what we find? We find this one, any again appropriately x k n0. If we put n0, then this one is obviously true, this inequality hold, so we write this one. And obviously modulus, that means if we change this minus, that means this to a minus b, we write b minus a, not a problem in modulus, so we write in this way. Then what happened? Then this one is happened. Okay, so here for all k belongs to natural number. Then again we write this one now here, xk whole to the power, sorry, xk not, k belongs to, k is any natural number, so we write xp difference xp less than epsilon, where p belongs to n. Okay, not a problem at all. Then what happened? Then we write in this way, where x n0 belongs to c. Obviously here x n0, here x k n0 belongs to c, otherwise we not write in this way. And obviously x p n0 obviously belongs to c. Okay, we not write here, but this was, these two are obviously belongs to c. Okay, then what happened? xk n0 obviously converged. Okay, xk n0 from a convergent sequence, and then this one is Cauchy. If we write this one now, xk n0 belongs to c, this implies that xk n0 be Cauchy convergent. Okay, and this implies xk n0 be Cauchy. Yes or no? Yes. Then what happened? We again erase some portion and going to further discussion of that. So here we write about that there exists an n1 belongs to natural number such that, okay, such that what, xk n0 difference xp n0 less than epsilon. Okay, because this one is Cauchy, and obviously kp are natural numbers, so here kp greater than equal to n1. Okay, then what happened? Again we write here, from 2 we get, from 2 we get, what we get? Difference xk difference xp less than what, less than there is here xk difference xk whole to the power n0 plus xk n0 difference xp n0 plus xp n0 difference xp. Okay, so how we write this one, xk difference xk n0 equal less than epsilon plus this one less than epsilon plus this one less than epsilon, 3 epsilon. Where this one happened? Obviously kp greater than equal to n1, and this one happened when xk n0 difference xk, that means kp belongs to this natural number. This one is not right more, so we also turn it. Okay, so what happened? We write this one now, xk difference xp less than 3 epsilon for all kp greater than equal to n1, where kp n1 belongs to natural number. Okay, so what we done? We done this one. This shows that x be convergent. Obviously this shows that what, this shows that, sorry, this shows that xk be Cauchy. Okay, then what happened? Then obviously Cauchy in where? In k. Okay, then this implies that xk be convergent. Yes or no? I think not a problem at all. Okay. So what happened? Xk conversion in K, and here then what we find? We find X belongs to C. Yes or no? Yes. Now we also write again. Okay. What do I write here? Again we write this one. Supremum of xk whole n xkn difference xk less than epsilon for k belongs to natural number and n greater than equal to some n0. Okay. Then what happened? This implies that norm of xk and difference xk less than epsilon for all n greater than n0. Okay, and this implies that x n converts to x. Okay, since k arbitrary. Okay, so what happened? Again, xn belongs to c and x belongs to c, and 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 what? And obviously, and cv xn belongs to c, or sorry, it's not cv here, and xn converts to x, and c norm b norm space. Okay, so c norm b Banach space. Not a problem at all. Too easily we do it, but not similar to others one. Okay, too easily we do it, but not similar other one, because we prove that means in last class we also proved some example of Banach spaces, but this one is some different. Okay, because this difference is need here, and in this question, that means in past days questions of Banach spaces, that means these examples are that means not this type of that means technique is not used here, because this one is not needed there. Okay, so we also prove this one c norm dot, this one is norm infinity, I think, be a Banach space. Okay, so today I stop here.